So these are applications which you see that which you can use in machine learning. Like speech recognition. If you have to recognize the speech of some persons, if you have to do a frequency matching kind of things, if you have audio signals, in that case you can use machine learning. And object recognition, there also you can use machine learning. Let's say if you have to track something like pedestrians or different kind of cars or trucks, anything it can be, which if you want to track it, in that case also you can use machine and deep learning. Plus engine health monitoring. Let's say if you have to find out the remaining useful life of your engine, or if you have to find out the faulty data of your plant or engine, then in that case also you can use machine learning and deep learning. Weather forecasting, if you have to forecast weather, there also you can use energy load forecasting. There also you can use it. Stock market prediction. Let's say if you have to predict the stock market, and if you want to identify that what will be a beneficial for you, that where you are going to invest money, in that case also you can use machine learning. In MATLAB there is a trading toolbox that which you can use it to log live data from stock market vendors. Machine learning can be used in IoT analytics, and we can't imagine as well IoT without machine learning and deep learning. So it is a part of IoT, because IoT means we have big data, right? Taxi availability, you can see the examples of taxi availability in Ola and Uber, and air flight delays. This is a here also you can use machine learning, because prediction of flight delay is very important. If accuracies are not high, if you can't predict in some cities of the world, if there is even a 1 second delay between a flight, if you don't know that that what is the delay time, then two plane can be crashed. Okay. Just wait. So do you hear right now? Anyone can hear me?
Yes, sir, we can hear you. Are you able to hear us?
Yes, I can hear.
Okay,
right.
Sir, it is my request that can kindly give me the list of participants so that I have to give it to my institution, that the following people are.
Sure, sir. We will share with you all those
Okay,
lists that who have
sir.
attended. How much time they have attended, everything I can share out with you.
Thank you, sir. Thank you.
Okay.
We will start from case study as well. There is one case study of Mahindra. They created a model road condition estimator using machine learning in MATLAB. So we'll discuss that what problems they faced this, and what was the outcomes from that, and challenges when while they were creating this model. So this was the problem that while collecting data like road surfaces and its conditions, different roads have different surfaces, different conditions are there. Diversified categories of road. As we know, there are different kind of classes of roads: class A, class B, class C. Uh, and also based on the terrain, I mean the surface of road, the driving style also can be changed. So these were the problems which they are facing it. And from this road condition estimator, if they were able to create this model, then what they could predict from that, like tire life. Please, can you mute yourself? I hear some noise. As well as you can use also this estimator you can use to find out the vehicle durability and aging impact on that also, as well as the mileage and fuel economy impact if you have this road condition estimator. So this was their output first of all, which they used this. They collected data, and like you can see here that they predicted as like this, like class A road is good road, class B is good road, class C is bad road, and class D is bad road, something like that. And to create this model, this was their workflow which they used it in MATLAB. Collect and label the data, pre-process the data, and further they extracted the features from that. When they had the features, then they use model in MATLAB. They generated a machine learning model. Then further the next step they optimize. This is you may say that is a workflow as well of machine learning. Plus, they deployed that model in Simulink to work on a dynamics. In real time model. So what they did, they used that model further in Simulink and they generated the code and they deployed it for real time applications as well. So this was the whole workflow which they used. One more case study of Tata Steel. Actually, the Tata Steel, they use where they use that MATLAB with machine learning. They save the 40% energy and cooling towers throughout the software algorithms. So first of all, about Tata Steel, the Tata Steel Group, global steel companies with an annual crude steel capacity of 27.5 million tons per annum. Plus, it is a operation. It operates in 26 countries and commercial presence in over 50 countries. To cool, I mean, when in this process from iron to steel, they use some 200 cooling towers in their plants across the world. And they are medium and high level range of cooling towers and as high as 1000 tons of refrigerations. Okay, they use it. The challenges which they are facing, that they wanted to enhance the efficiency of cooling towers. Why? That they had a manual frequency, means whenever cooling towers are required, towers were on. Is it fine? It is fine. But when coolings were not much required, still cooling towers were on. When it was not required, it was on. When it was required, then it was off. Means you may say that because of that efficiency were not so much high for that. So what they wanted, Dr. Sarkar, who is dealing with this project, he said that if we can reduce the energy consumption of the pump and the cooling fan, then energy will be saved significantly. To do that, we have to install the variable frequency drive. So when they have variable frequency drive to control this cooling tower, so they can save the power consumption, right? If it is constant, if it is running constantly manually, then so much energy was going. So based on the because of variable frequency drive, whenever it will be required to on the cooling tower, that will be on. Whenever it is required to off it, based on that it will be off. So what they did it for that, they created a replica of this original plant in Simulink. That is called digital twin as well. Okay. So further, they were collecting data from a real-time plant. They were using that data on virtual plant, and they created a forecasting predictive model for that using machine learning. That if current data is this, then what will be a frequency to drive that cooling tower? So like this, they were able to predict the frequency to on the cooling towers, and further they optimize that VFD, variable frequency drive. So like this, they use the MATLAB and machine learning to optimize the variable frequency drive. Some other case studies in automotive company BMW, there is a Mercedes-Benz also, there is a Honda company and semiconductor company, that is ASML. So now what is machine learning? Machine learning teaches computers to do what comes naturally to humans and animals. Means the things which we can do, humans or animals, that facility we are giving to machine, that machine will do for us. So they learn from the experience, and machine learning algorithms use computational methods to learn information directly from data without relying on a predetermined equation as a model. Okay. So what it means, that we don't require any mathematical equations. Later we will understand that where you can use machine learning actually. So here we don't require any mathematical equation. We don't require to solve any mathematical equation. We don't have to estimate any parameters. Machine learning learn directly from data. Plus, the algorithm adaptively improve their performance as the number of samples available for learning increase. So when you increase the number of samples, your machine learning accuracy will be high. This is a machine learning. Okay. Now, more data, as by definition, more data, more questions, and better answers, right? So, machine learning algorithm find natural patterns in data that generate insight and help you to make the better decision and prediction. What it does, it when you provide the data to machine learning, it identifies some kind of patterns. Based on that patterns, it differentiate your data. Okay. So like this, it is used in every day to make a critical decision in medical diagnosis, stock trading, energy load forecasting, and more. Like you are watching a YouTube video, you are watching Netflix, you are watching Prime Video. In that case, whatever you watch it, based on your pattern of your watching, Amazon, Netflix, or YouTube suggest you some videos. That is a machine learning there which they use it. Okay. Plus, some retailers go inside to find out the customers' purchasing behavior based on that, like your Amazon and Flipkart. That what you are purchasing, based on the pattern, they will suggest you some products to purchase that. In real world applications also, you can use machine learning in computational finance for credit scoring or algorithm trading. And you can use in image processing and computer vision as well for face recognition, motion detection, and object detection. Computational biology machine learning, again, very widely it is used for tumor detection, drug discovery, and DNA sequencing. Machine learning is used for price and load forecasting as well. Very widely, machine learning is used in automotive and aerospace and manufacturing as well for predictive maintenance. They use it. Predictive maintenance already, which we are discussing one example just in previous PPT, to find out the remaining useful life or to find the faulty and non-faulty data from your machines, right? In natural language processing, like already we discussed, like speech recognition and all this kind of applications where you can use machine learning. Now, how machine learning works? So first of all, machine learning uses two types of techniques, that is supervised learning and another is unsupervised learning. Here you can see this is supervised learning and this is unsupervised learning. So how again here you see supervised learning is divided in two parts: classification and regression. So we use supervised learning when we have a supervisor. Let's say that your supervisor is saying you go in the market, collect the data, and your supervisor will give you a feedback on it. Your supervisor will give you output based on your input which you collected from the market. He will identify the pattern. It will give you an output. So what it means that in supervised learning you have inputs and outputs both. You are using inputs and outputs to creating a machine learning model, and further you are using as a predictive model to predict on new data. Okay. So again, supervised learnings are divided in two parts: classification and regression. Classification is also called discrete learning, and regression is called continuous learning. We will discuss it. And clustering, where you don't have any output, just you have inputs. Based on the inputs, you have to find out the pattern in it. For example, like when you capture images from your camera, your images are automatically clustered as a names, as a place, or some other names, right? Second thing, when you search something on Google, whatever word you type on Google search, based on that only you will get the data. That is also example applications of clustering. So in clustering, there is no output. We find the natural groups and patterns from the input data only. In classification, it is a discrete learning. We take some sets of samples and we assign some classes like good, bad. If it is temperature, then we can assign like this. This group is comes in a this group comes in a low group, and another group come in a high, and another one in a medium, like this. Same for regression means for each and every input you are getting a numeric output. That is a regression means that's why it is called a continuous learning as well. Okay. Now, how do you decide which algorithm to use? So this is very important. How you are going to decide, because there are some issues also here. I mean, some not a issue we can say. Means you will face some problems to identify the algorithm for your data. So choosing the right algorithm can seem overwhelming. There are dozens of supervised and supervised machine learning algorithm, and each takes a different approach to learning. So it is not there is not a best method for one size and fits all. There are different algorithms based on your data. It's not like that any algorithm you can use to create a machine learning model. So you have to you have to identify that which algorithm will be best for your model. Second, finding the right algorithm is partially just trial and error. It is like a hit and try, like kind of things it is. Even highly experienced data scientists can't tell whether an algorithm will work out trying it out or not. Why? Let's say that if you are if you have data and you are using ensemble method, and you are working since 6 months, 1 year, maybe two year, and the accuracy which you wanted, you are not getting it right. Then your all time which you spent there, it will be ruined. So better to use some kind of reverse engineering. First, identify the which algorithm will be a base for your data. Then you go for further learning of that algorithm. So next, the algorithm also depends on the size and type of the data you are working. That is also very important. The insight you want to get from the data means what you want from that data, and the things which you want from that data, where you are going to use it. That is also very important when you are going to use the machine learning for your data. So here you can see algorithms are classified based on your learning. If you are using supervised learning, in classification you can go for support vector machine, discriminant method. These are the algorithms. For regression also there are some specific algorithms, and for clustering also there are some specific algorithms. Okay. So later we will see that how MATLAB will help you to, even if you are using classification, then how you can extract the good algorithm for your data. Okay. Now, when should you use the machine learning? So this is very important. Let's say that if for your data there is very complex to create a mathematical equation. So there any predictive analysis or analytics will not work. You will go for the machine learning or deep learning in that case. So like handwritten rules and equations are too complex, right? If there are handwritten images and you have to classify that what is there, then it is not easy to create a mathematical equation for that. Then you are going for the machine and deep learning in that case. Again, like in face recognition and speech recognition, how you are going to create equation, it will take 4 to 5 years just only to create a mathematical equation for that. In that case also you can use machine and deep learning. And the rules of a task are constantly changing, because mathematical equation, when you create it, it is fixed. You can't modify that, right? So if rules are changing continuously, in that case, for example, fraud detection from transaction record, because fraud can be from ATM cards, frauds can be from online banking, right? So in that case also you can use machine and deep learning to detect this kind of fraud. Plus the nature of the data keeps changing and the programs need to adopt. Again means you have to create some kind of models that which can adopt with current data. So again machine learning, it can be optimized itself based on the new data. So like in trading, continuously it is changing. Energy demand forecasting, every day the energy demand is increasing all over the world. Shopping trends are also changing every day. Today you are wearing this kind of trend, and next year it will be different, right? So again this challenges which whatever we see in previous PPT. What are the challenges which we got from that? That data comes in all shapes and sizes. There can be a different shapes and sizes of data. How to maybe you can have a big data which takes long time, or maybe data which cannot fit in your memory. Then how to handle with that kind of data? And the challenges like pre-processing, you require some special knowledge for that to do pre-processing. Pre-processing, like if you have noise in your data, then how you are going to design a filter to remove that noise. If there are outliers, if there are missing data, there are some kind of trending, then you have to detrend it. Lots of things are there that which you have to do as a pre-processing on your data. Now when your data is ready, then to fit the model based on your data, to extract the features and all this kind of things, it takes time as well to find out the base model to fit the data. Okay, so these are the challenges which we just discussed in previous PPT pages. Before using machine learning, just ask these three questions yourself. That what kind of data are you working with? Do you have a data with input and outputs? Do you have data just inputs if you have to find out the pattern, or do you have a time series data? Do you have a random data, like when you are throwing a dice, then you are finding the probability that what will be a probability of 6? That is a random data, right? That you can use probability distribution in that case. Okay. If you don't want a high accuracy or some vague kind of data you have, then you can go for the fuzzy logic as well. So these questions, and second is that what insight do you want to get from it? Means what feedback, what output you want from your data, and the insights which you are getting, where are you going to apply it? Based on that, you can choose that are you going for the supervised learning? In supervised learning, are you going for regression or classification, or you are going for a unsupervised learning in that case? Now about workflow, how it works, machine learning. So first step is that access and load your data in MATLAB if you are using MATLAB. Okay, so to access data in MATLAB, lots of files and formats are supported. You can load from Excel file, CSV file. It can be a scientific data and file from there also. Maybe you can have database, or you have data in your clouds. This is the first step, and next the data which you access, that will be a raw data, right? So again you have to do some kind of pre-processing on data to remove the noise, make your data ready for the machine learning, for the feature extraction in machine learning. Then the next step, that whatever pre-processed data we got it, we require to extract the features. Like if you have time series data, then or static data, then your features can be mean, median, standard deviation. Let's say if you have data from motors, rotating motors, so from there you require some kind of RPM data and other tachometer data also, right? So in that case you require a frequency domain feature as well. When you have a feature, then further we go to train the model. Means we access the data, we pre-process the data, we extracted the feature, then we are going to train our model. After training, we require to optimize. We require to iterate our model to optimize the hyperparameters of it. Next, when my model is ready, you can deploy your model in a production system, or you can deploy in a hardware, or you can create a standalone applications of it. So this is the working work of machine learning. This is the workflow that how you are going to use the machine learning. Now, what you can do machine learning with MATLAB. I mean, with MATLAB, how it helps to create machine learning algorithms in this case. So in MATLAB, we have some kind of apps like you can compare different approaches like logistic regression, classification tree, support vector machines, ensemble methods, and deep learning. It will let you know that based on your data, which algorithm will be best. Okay. Then you can apply auto machine learning to optimize hyperparameters and your models, and further reduction of your features like PCA, principal component analysis, you can use to reduce the features of your inputs which you are giving it. Okay. Now you can integrate machine learning models into enterprise systems, clusters, clouds, or you can deploy in a hardware for the real-time applications as well. Okay. So let's plus you can generate automatic code also for that. If you are getting the sensor data, then you can generate a code you can deploy again in embedded sensor for embedded sensor analytics. Okay. Okay, now we will go in MATLAB. I am going to choose this example. That is a diabetes example. I am going to take it. The inputs which we have here: plasma, glucose, age of persons, number of pregnancies, and insulin and body we have as a predictors. We have a value also. Based on these predictors, we have to predict that if a person is diabetes or without diabetes. Okay. So based on this data, the objective which we have, that first we have to prepare the data, then we have to exclude the redundant features from that data. If there are some redundant features, then how to exclude that. Further, we require to rank the features. Means I want only that features which are responsible to create my models. Then further we are going to create a predictive model. The solution is that in MATLAB there is a live script for the prepare data, rank the feature. You can write your codes, and we have a machine learning app which will tell you which will tell you that which algorithm will be a base for your data. Okay. So let's switch to MATLAB right now. So this is a MATLAB. When you first time open, it will be open like this. Okay. Just wait a minute. Okay, when you open first time, your MATLAB will be open like this. This is a command window. If you have to visualize any variable, just define it here. It will be visible like this here. Okay, this is the variable. It will be visible. Now here, okay, just wait a minute. There is some issue. Just 1 minute. Let me close this MATLAB and open this again. Actually, this MATLAB is open since the morning, so that's why I am opening it again. So further, I will show you one more example. This is the example which you see that if a person is a diabetes patient or non-diabetic patient, is a classification. Next example which I will show you, that is a regression, that I have age and weight of person, if a person is male or female, if a person is a smoker or not. Based on this data, we will predict what will be a systolic pressure of that person. And okay, let me check it if it is open. Okay, it is opening. Okay, and based on this data, we are going to predict the systolic pressure. And further, what we are going to do it, to select the feature, we will identify want to apply the PCA for feature transformation for the high accuracy. That also you can I will show you how to do it, and further how to optimize the hyperparameters. Hyperparameters are that parameters which are more sensible for your model. Okay, means if you change a little in your hyperparameter, then your whole model will change it. Okay, this is a command window. This is a current access, current folder. Any file which you save it as a default, it will be saved here. And this is a workspace here. So let's say if you define any variable like this, so as a default, it will be appeared in a workspace here. Okay. And here are some tabs also, these are plot tabs, and there are some apps also. If you want to access, if you don't want to write algorithm, you can use these apps also. Okay, so just wait a minute, it is still a little busy. So here you can see group wise these apps are given here like this. Okay. Now if I select, let's say that this is my data here in workspace. Okay. If I want to plot it, there are different kind of plots based on your data that this plots will be visible. I want, let's say that simple line plot. Just you have to click on this plot and your plot will be visible. Fine. Just 1 minute. Okay, we are going to start from that demo which we were discussing it. Fine. So let me show you the Excel file that what data are available there. So here you see we have 10 columns here, and the last column is output. Okay. So the first column is pregnancy, then glucose, skin thickness, insulin, BMI data, and the age of persons. And the outcome is as a 1 and 0, means 1 is for if a person is with a diabetes, and 0 means he is without diabetes. The second thing, here you can see pregnancies can vary. It can be 6, 7, 8. Here you can see your pregnancies data can be, it is a crisp data. Pregnancies data cannot be 6.5 or 6.4 or like this, something like that. Plus outcomes also are crisp data, 0 or 1 only, right? Here you can't say that your outcome can be a 1.5, means someone is 1.5 diabetes or 0.5 diabetes. It is not a fuzzy logic actually, right? So this is also crisp data. Whenever you have a crisp kind of data, what do you have to do? You have to convert as a category before applying it, to apply the MATLAB operators. In this case, you may not apply, because here you are giving you will give an input integer, right, as a crisp data. So we require to convert this as a category before going to apply it. Okay. Now we got that what kind of data we have here. Okay. So here these are variables which we have as inputs and outputs. So here 9 we have inputs here. Sorry, 8 inputs are there, and the last one is output as a 0 and 1. So first of all, we are going to read this table. If I read this table, that table will be imported in MATLAB. Okay. So here is my table. So in workspace. So as I told, when I execute that table, it will be appeared here. So this is my table. Next step, what we are going to do it, if I have any missing data, then I am going to identify that what kind of missing data I have, where I have missing data, and how many missing data do we have. So if I run this, so here you can see answer is showing 0, so it means we don't have missing data. In case if you had a missing data, using this live script, if you go in insert, if you go in tasks, there are some kind of pre-processing tabs like clean missing data and remove, smooth. So if you have if you want to do pre-processing using live script, just click on this. That depends on you that what are you going to do, smooth data or clean missing data. When I click on this, a template will be opened here. Okay. So when this template is opened, just provide your data where you have missing data, right? Here, let me show you that like this. Let's say I have one variable here, a is equal to some values, okay, like this, NaN. When you load in MATLAB, you have missing data, it will come as a NaN, not a number, right? So in this case, we have two missing data, right? So what I will do, I will select that variable where I have missing data. Further, here, if you want to fill that missing data or remove that missing data, you don't want to do anything. First thing, Second thing, what kind of algorithm are you going to use to fill that missing data? By constant value or by previous value, next value, nearest value, depends on you that what algorithm are you going to use. So here you can see that wherever I had missing data, I use the linear interpolation, and wherever missing data where that is filled. So my output will come here. So here you can see here, if I type here this clean data where you can see now that missing data are filled, right? So you can use this template. Further, if you want to modify in this code, you can convert this code as a editable code like this. So this is the advantage of using live script. You can visualize your graphs, you can visualize your numeric data, everything in a same live script, and some kind of tasks are there which you can do it in live script directly. Okay, so it will save you your lots of times as well. Okay, we don't have missing data. Now I want to find out that how many patients are with diabetes and non-diabetes. So just this is a histogram of the last column, okay, of my table. So here you can see somewhere around 500 are with non-diabetes and around 250 are with diabetes. I want to find out that if a person is above 50 years old, then what will be, how many patients will have diabetes and how many patients will have not diabetes. So you can see in the first case, if I took all ages people, here non-diabetes people were less. When they cross the 50 years age, this gap is reduced, right? So both diabetes patients are increasing in this case. Okay, now next step, already we have this feature. We are going to find out the correlation of all variables which we have. So there is a CORR correlation plot here. Just click on this. This is a linear correlation. When you go in the help, there is a non-linear correlations also. You can provide different kind of options there to identify the correlation between variables. Okay. So here you can see this correlation graph here. Just I am undocking it from here, then we will discuss more. So on x-axis we have variables, on y-axis also we have variables. Here you can see it. So these are variables like pregnancy is there. This is the histogram of this pregnancy data, how it is distributed. So this is the pregnancy, and it is showing you that how it is correlated with glucose. That is 0.13. Maximum value is 1. The correlation value will lie between -1 to 1. Okay. If your value is between 0 to 1 and it is near to 1, then it is more correlated. It is near to -1, that is inversely highly correlated. Okay. So by this, like if I am talking about insulin, here you can see insulin 0.33, 33% it is correlated with glucose. So why I did this correlation plot? This is very important. If any variable, predictors, not output, I am talking about predictors. If any predictors are highly correlated with each other, you can remove one variable from it, because you don't require both variable as a predictors if they are highly correlated. Okay. Plus these variables have to be highly correlated with output, not in themselves. Glucose have to be highly correlated with output, means if a person is with diabetes or not diabetes, but within them it has to be uncorrelated. Okay. Second is I am going to convert that output as a category, and I am replacing 0 by no and 1 by yes. So maybe in future I will not remember that what is 0 and yes, so that's why I am replacing that by no and yes. So you can see in this table, the last column which you see, 1 is replaced by yes and zeros are replaced by no here. Okay. Yes means they have diabetes and no means they don't have diabetes actually. Okay. Next, I am going to do a ranking of that predictors. So we are using here minimum redundancy, maximum relevance. Okay. So here you can see in this graph, glucose, BMI, pregnancy. These are very highly correlated. Means this graph showing that from left side, this variable left to right, the correlation means the required of your predictors are decreasing. So in this case, we can remove this last three predictors. We can use this first 4-5 predictors, because this is highly correlated with output. It will be required this and this. Still, you can see the value is not near to 1, but still apart from this one, we can use first 5 variables, and we can remove that last 3 features. We don't require that features to train our model. Okay. So now we have this matrix, as well as we also got that what features we require to train our model. And the next step is to identify the model that which machine learning model will be a base for this data. Okay. So what we are going to do in this case, if I go in app, and if I go here, you can see machine learning and deep learning group. There is a classification learner and regression learner. In our case, we are going to use classification learner. We'll use this app to identify that which algorithm will be a best. Okay. Any kind of query or questions you have, you can type it here. We will answer that when this session will end. Okay, this app is open right now. I am going to click a new session from here, and I am going to select that table. So here you can see last is automatically selected as the output, and the remaining are as the predictors. Okay. And further validation, that how are you going to validate your model? You have two options: cross validation and hold out validation. In cross validation, like you see that as a default it is 5-fold, right? So what it means, if it is selected as a 5-fold, 6-fold, or 7-fold, now it is 5-fold. So it means that your all data will be divided in 5 parts, all samples. And on 4 part your model will be trained, and on the last part it will use to find out the accuracy of your model. So like this it will do 5 times, and 5 accuracy you will get it, and the average accuracy will be a final accuracy of your model. Second is hold out validation. In this case you can hold some percentage of your sample to validate it later, means when your model is created. Or you may choose no validation. If you have already data in a different file, you can load it, and when your model is ready, manually you can validate that. Further, hold out validation you are going to use when you have a big data. Sorry. If you don't have big data, then you can go for the cross validation. So in our case, we don't have big data, so we are going for the cross validation. Why hold out validation will use for big data? Because it will take a less time. Already you have a big data, so you can go for that. Your accuracy will be automatically high. But for big data, if you divide your data in a fold, it will take a long time in that case. Okay. Now I'm going to start the session. Okay. So here by color you can find out that what is the relation between your predictor. Are they differentiated or not? Still you can see that they are very highly correlated, glucose and pregnancies, right? They are in the same almost group. Further, you can use PCA also, principal component analysis. In this, so first is that we have to remove that features which we don't require, right? So this is our graph. So we have to remove the blood pressure, diabetes, and skin thickness, right? So here I am going to remove this blood pressure, diabetes, and skin thickness, and you see that how perfectly this ranking works. Blood if if someone has high blood pressure, it doesn't mean that person is with a diabetes. So the ranking is working well in this case also. Not only this, the person is fat, you can't say that the person will have a diabetes. It's not so much dependent, right? But glucose, BMI, these are very highly related to important, as well as age too. Okay. So the features which we don't require, we already untick that. Okay. Further, you can use PCA also. I am not going to use PCA already. I have a less sample in my case. And here you can see there are different kind of algorithms here. Decision trees, discriminant analysis, logistic trees, Navy based classifier, support vector machines, nearest neighbors, and all this. Now our next step is to identify, as I told, which algorithm will be a best. If you select all, it will train this model on your all algorithm. Okay. And if you select all quick train, it means it will choose only that algorithms which is feasible with your data, which will give you a quick solution. Okay. So I am going to choose this quick all. Further, if you have a big data, so it will, of course, the processing will be slow. So you can choose parallel computing also here. Here is the option for parallel computing. When you choose this, your iterations, let's say I have 4 cores in my machine. If I choose parallel computing, 4 MATLAB will be open in 4 cores, and at a time 4 model will be trained. So in our case, we don't have big data. I'm not going to choose it. Now I'm going to click train. So training is done here. You can see accuracy. Whatever algorithm will be there, if it has a high accuracy, if in comparison with others, it will be highlighted. So tree and KNN both have equal accuracy. So both are highlighted. Now further, I selected this KNN, and if I go in advanced, you can tune the parameters from here. Okay, there is the option to tune it. And if you have to tune the hyperparameters, let's say that here I am going to choose optimize KNN. Okay. And from here I am going to in optimizer options to optimize my parameters. I am going to choose the same, and I am going to use the 30 iterations for this. Okay, now I am going to click the train, and let's check that what accuracy will be of this after optimizing the parameters. So optimization started. This graph is showing you a minimum classification error. This error has to be less with respect to iterations which you see on x-axis. Okay. You may say this is a cost function as well. So it will run for 30 iterations. So two outputs you can see here. One is estimated minimum classification error, and another is observed minimum classification error. So now you can see accuracy, 1% accuracy is increased in this case. Further, if you are not happy with it, more you can optimize, you can increase the iterations. Okay, I am not going to optimize this again. I am happy with that. The 76.4% is fine. I can check the confusion matrix of it. So in confusion matrix, on x-axis that is predicted class, and on y-axis it is showing you true classes. Okay, this is a relation between predicted and true classes. So in case of no, means without no diabetes, 440 samples are perfectly classified as no, and remaining 60 are misclassified as yes. In case of S, you can see 121 were misclassified as no, and 147 are perfectly classified as yes. This is a confusion matrix. There are some other plots also, like scatter plot is there. So wherever you see that cross that is showing error, okay. When you are happy with it, from here you can generate functions for automation. If you want to generate C code for automation, so here is the function, you can use these functions, right? In this case, this function is used. Okay, if I go in help, so you can get a help like this, and further you can see that what more properties you can provide it. So you can see that here some in one example it used in a single line to create a CNN model. Okay, what I further if you don't want to optimize this, okay, if you don't want to optimize this, what you can do here, you can sorry, if you don't want to modify your algorithm more, then what in that case what you can do, you can export it as a model, or you can export it as a compact model. So depends on you that what you are going to export as a model or as a compact model. If you export as a compact model, then you are going to generate a C code, or you are going to interface with Simulink. Or if you export it as a model, then you are going to use this model as a predictive model. So let's rename this model as a PP. I am going to rename it, and I will open this here, and PP will be appeared here. Further, you can save this model for prediction. So to predict, what we do, PP dot predict fun. Okay, and here you have to provide the all input arguments. So it will predict that if a person is diabetes or non-diabetes, like this here. What I did, the code which I generated from there, I copy pasted it here. And further, what I am doing it, I am executing that function here. And I am using a train classifier or predict fun, and the first sample I am taking, and I am predicting that what will be output if a person is with diabetes or non-diabetes. So here you can see answer is coming as a yes, means when I use this predictor, then it is showing me that person is with diabetes. Okay. So this is the whole process of classification using machine learning, and further if you want, you can export as a PDF, as a Word, as a HTML, or as a LaTeX code. Okay. Okay, fine. We will go for the next example. That is a example of regression. So this example we are going to use it. In this case, all process is same. Only it is a regression instead of classification. Okay. So here I am going to use systolic pressure as a output, and remaining are as my predictors. Okay. So here I have this data. So you see here, we are not talking about this all these columns. We are talking from second to sixth column. As an input, we have a sex, if a person is male or female, what is the age of person, what is the weight of person, if a person is smoking or not, and then we are predicting what is systolic pressure. Once when you train this model, you can predict that if what is the systolic pressure of that person. Okay. So in this case here you see this second column is as a male and female. This is characters. You cannot apply operators. So we have to convert as a category, and if a person is a smoker and non-smoker, this is a Squiz value. A smoker, it can be a smoker or non-smoker. It cannot be 1.5 or 1.6, something like that. Squiz value this is. Then here we have to convert as a category. So we have to take care of these two columns when we are going to create these models. I choose this model because there are some characters also that you can use in machine learning to train that. Okay, that's why I choose. So I am going to clear output, and I choose the example that anyone can understand it very easily. So what I am doing it, first of all, I am reading that table. This is my raw table. Okay. Now further we are going to extract that variables, predictors and outputs, which I am going to use for the training purpose. And further in this section you can see we are converting as a category, as a sex column and the smoke column. Okay, and in smoke column again we are converting 0, 1 as a category, and we are replacing 0 as a no and 1 as a yes. Okay, fine. Now our table is ready as a cast, this table. So we are going to use this table to train a model. So in this case again we have to select that which algorithm will be a best. So here in this case we are going to choose regression learner. Okay, I am going to start the new session in this case, and I am going to select that table which I have to train it. Okay, again the validation is same as we discussed in the case of classification. I am going to do a next. Now here you can see a relationship between output and input. Let's say I am going to choose weight. So what it is showing you that based on the weight, how your systolic pressure is varying, and you can see how these data are distributed. It is impossible to create a mathematical equation for this kind of data. So you can go for a machine learning again, and whatever categories were there, let's say this male and female. So you can see a box plot of it like this. This is a box plot. Okay. So again, I'm not going to use the parallel computing. I'm going to select only that algorithm which will be supported for this data. So I use all quick train, and here all features I am going to use it, not going to deselect anyone. Data are not so big, I am not going to use parallel computing. Now just I am going to click on train. So this box plot which you see, that was the measured one, and that is predicted box plot. And in all this algorithm, the linear regression model is good. The root mean square error is this one. So this is perfect when you are happy with it. There are some other plots also you can see it. This is the predicted with true line, and all your samples have to be on this line. There are error plot also. When you click on this, you will get the error plots also. These are the errors. This is a 0 line error. Okay, this black one, and these are the errors after prediction. Means input predicted output minus original output. Okay, same process. You can generate code, or you can export as a model. Fine, the same process it is like that. And here I copied that, I pasted that algorithm in the same script file. Okay, I am using as a local function here. Now I am going to train that model, and root mean square error is showing this. Now I am going to predict on that. I am going to use the second sample, and I want to predict that what will be a systolic pressure on it. That is 119.6149. So now we have model, and if you know the patient age, sex, if a person is a smoker and non-smoker, I can predict that what is the systolic pressure of that person. So this was about machine learning. examples which I showed you. Now we have time, we can go for deep learning as well. Right now, if anyone has question, you can ask me. Here you can write in the chat if anyone has any question till now. Then we can go for deep learning. Any question? I am audible. Reinforcement learning. Okay. We'll have a session on reinforcement learning later. Right now, actually, today we are discussing about machine learning and deep learning only. So next session we will try to arrange for reinforcement learning as well. Okay. Fine. Okay, I guess no question. Please proceed. Okay, fine, fine. Thank you, sir. As in MATLAB, reinforcement learning is already added in MATLAB. From 2019 you can use it here. We will try to arrange a session on reinforcement learning later. So now about deep learning. See, deep learning is also a machine learning technique that teaches computers to do what comes naturally to humans. Means the things which we can do using machine learning, we can do in deep learning also. But in deep learning, the good thing is that here a computer model learns to perform classification tasks directly from images, text or sound. So in deep learning, we don't have to extract the features. Your deep learning network will do it for you. Okay. So here this first figure which uses that is a replica of machine learning. Here you can see that if I have to identify the car, then what we are doing, we are extracting the features of that car and we are providing to machine learning, and it is detecting that this is a car. And this same for the deep learning. Here we don't require to extract the features. There are layers to do this task. We only have to create the layers, and that hidden layers will do for you everything in this case. Okay. Second thing, when you are going to use machine learning and when you are going to use deep learning. Let's say you have big data and you feel a problem to extract the features from your data. If you have row samples in thousands and lakhs, you may say, then it is not possible to extract the features from all data. Or in some cases where there is impossible to extract the features manually, then you can go for deep learning. As well as if you have a very big data, go for the deep learning, otherwise go for the machine learning. Okay. So image you can use in machine learning also. The thing is that you have to extract the feature whatever kind of data do you have. In deep learning you don't have to extract the feature. So if you don't have big data, I suggest don't use deep learning, go for the machine learning. Or if you don't have big data, you can use shallow neural network also, where there is only one hidden layer. Okay. So in deep learning, it is also called deep learning because of layers. When you increase the layer like 8, 10, 20, 100, 200, then it is also called as a deep learning. It extracts the deep features from your data. That's why also it is called as a deep learning. So there are so many softwares, languages to use deep learning, but here I am discussing why MATLAB, why you are going to use MATLAB for deep learning. What is the benefit of using MATLAB for deep learning in this slide? So here you can see MATLAB is fast. If you are providing the same environment for TensorFlow or Caffe, it is 7 times faster than TensorFlow, 4 times faster than Caffe. Not only this, like pre-trained models like VGG16, VGG19 or AlexNet or ResetNet 50, which are already pre-trained models and which are open source models, you can import in MATLAB and you can use that pre-trained models to retrain your data. Means already that models are optimized, you don't have to optimize it again. Import in MATLAB, use it as a transfer learning. Okay. And further in MATLAB, NVIDIA GPUs that are supporting to accelerate your deep learning models. And in deep learning, we have automate ground truth labeling apps as well. Okay. So to label your data, you don't have to do it manually. Use that apps to label your data. You can work with models like Caffe and TensorFlow Keras after importing in here in MATLAB. So let me show you that about labelers, that how you can use that labelers. Okay, how to label your data. So first of all, here you see labelers. What kind of labelers do we have here? So if I go in signal processing, if you have time series data, you can use this IDEO labeler to label your data, and then you can automate that process. Okay. Same if I go in image processing, we have a image labeler and we have a video labeler as well in this case. So let me show you an example, a small, that how this labeling works. I'm searching actually image, that which image I can show you for labeling. Okay. So this is a labeler, and first of all, you can load a video or multiple images. Yeah, for multiple images, you can use this. I am going to add image from folder. Okay, I am going to use this image. So this is a pre-process again, that if you don't have ground truth data, then how you are going to label this? Let's say that I have to create such kind of model that I will use in my car. Let's say I have to design an automated driving car to detect that this is a bicyclist, this is a car, and this is a pedestrian, some kind of. That is the semantic segmentation and semantic deep learning. So what you have to do, just click on this label. Okay, give the label name. Let's say I am going to label the car. Here is the car. And are you going to use pixel labeling, pixel based labeling, or rectangle? Depends on you. If I choose the pixel based labeling, and what I can do, I can use from here assisted freehand, and I am going to start this label like this. Fine. So this is my car. I labeled this. Same again, I will go in label, and let's say that bicyclist. Here you can provide the group as well, and again pixel level labeling I am going to use it, and you can choose from here this, and you can label it like this. It is labeled. Fine. Again I am going to click label and pedestrian. So I am going to choose the pedestrian, and in this case I am going to choose the rectangle. Fine. So I can label this like this. This is a pedestrian. Okay, something like that, and I can increase that. This is a pedestrian. So when you have multiple images, here is the option that you can automate this process. Further, you can choose the algorithm, that what algorithm do you want to automate this process, and when you're done with it, you can export to file and workspace as well. Further, there is a sub level also. Let's say that I am choosing the car. Actually, this is a semantic labeling, so pixel based. So I can't use sub level in this case, but in this case I can use in pedestrian, and I can create a sub level also. Let's say that I am going to choose a sub level as a hair. Okay, I will select, select I will this, and I will choose this as a hair or as a face or something like that. So you can sub label also. You can provide the attribute also. Attribute means if I am labeling the car, I can assign that what kind of car I am labeling. Is it a sedan car, it is a Alto, or it is a different kind of car. Okay. So when you are happy with all this labeling, you can export this data to workspace. Depends on you that where are you going to export it. So here all your data will appear in GTruth, and this data you can use for deep learning. Okay. So GTruth, if I type it and dot label data, here you will have a label all data. This is the part that where your images is saved. So like this you can use labelers. Okay. So we have labelers, so it is very easy to work on the work in deep learning. Next, the challenges which you can face. Already labeler I showed you. Some challenges are like there are multiple frameworks and libraries. Which library are you going to choose? That is also a big challenge in deep learning. Training and tuning of network, that is also very important. How you are going to train and tune your networks, and what is the hyperparameters which you are going to tune it, and further you require to deploy in a hardware also. How you this all things you can overcome in MATLAB if you are using MATLAB. So already you saw this labeler app, that how you are going to label it. Okay. Now there are some already I told there are pre-trained models that you can import in MATLAB, and you can use that pre-trained model for your data. Okay. So we have to design a layer. We have this deep learning network designer app. So you don't have to design this layer manually. Just drag it from here and drag it here, and provide the parameter value in right side, and your layers are ready. Just use this layer. There is the option to export this layer, and use this layers to train your model. Fine. And from 2020. Here you can see there is a one app here in machine and deep learning, that is the experiment manager. Okay, you can use this to design your complete deep learning model using experiment manager. Further, you write your code in MATLAB, generate a C, C++ or CUDA code. There is a GPU coder in MATLAB to generate CUDA GPU code, CUDA, that is called CUDA, to deploy on GPU hardware. So after generating a code, ARM, NVIDIA, Intel, these are the hardwares which are supported for deep learning models. You can deploy it in MATLAB. So all this process you can do in MATLAB. So this is the framework of MATLAB using deep learning. Access your data. Okay. After accessing data, there are large data set. I will let you know that if you have a big data and lots of images, thousands of images, then how you are going to use this to create a MATLAB to create a data store for that. Okay. And further design it and train it, label it and train the model. So for this you can scale in GPU also. There is a parallel computing in MATLAB that is supported to iterate your iterations on GPU cores. Okay. And next, the last is you can deploy in hardware for real-time applications as well. So in our case, I am going to show you one example how to detect the face of a human. I mean gesture of a human. Means if a person is smiling, or if a person is weeping, or if a person is angry, like that. Okay. So I am going to use CNN, convolutional neural network, or we say CONB net as well for that. Okay. So why I am going to use CNN in this case? CNN is very good to use for the text and images, and especially for the classification. Okay. So why to use the CNN for deep learning? CNN eliminates the need for manual feature extraction. We don't have to extract the features manually. The features are learned directly from the data. CNN can be retrained for new recognition tasks. This is very important as we are discussing about transfer learning, right? So you can use that pre-trained CNN to retrain for your new data as well. And CNN produce state-of-the-art recognition result. Means till now there is no other neural network, deep neural network, which can challenge the CNN. So its accuracy is very high of CNN. Second thing, this CNN is a feed-forward network. In any deep learning, when you train it, there is a back propagation. But network can be a recurrence or a feed-forward. Recurrence type of network, there is a feedback as well. But in this case, it is feed-forward. Means output of layer will go to the next, then next. It will not go reverse. Okay. In recurrent networks, only you use feedback kind of network because you have to forecast kind of things. Okay. So deep learning workflows, it works like this. Your inputs, this is means your data store, and here are the layers, and here we are classifying. So your also CNN can be used in pathology reports, like to visualize the cancer cells. CNN also can be used in self-driving cars to detect the objects, as we were discussing before. Okay. So how CNN works actually here? A CNN can have tens or hundreds of layers that each can learn to detect the different features of an image. Okay, fine. Filters are applied to each training image at different resolutions, and the output of each convolved image is used as the input to the next layer. As I told, it is a feed-forward network. So it will start extracting features from very simple, like age detection, resolution of it, all these things, and later it goes to detect the advanced feature of it. Further, it will remove that redundant features which will be not required during training as well. Okay. So CNN can be used for text, sounds, and video extractions as well. So I am going to show you one example of CNN. Okay. So first of all, what you have to do here, just create a folder. First of all, there where you are going to save your samples. It can be a time series data, or it can be any kind of data. It can be images, whatever you have. Just create a folder and give a subfolder name by a class name. Like in this case, the classes which we have: anger, contempt, disgust, fear, happy, surprise. So in this case, we have 6 classes. In every class subfolder, save your samples based on that. Okay, like this. So anger sample will come here, contempt samples will come here, disgust will come here, and fear will come here, and happy will come here, and surprise will come. So like this, you have to create a data store for that. So in our case, that is a image data store. Now we are going to create a data store now. To create a image data store, just we give a command image data store. This will be a path of your image data store. It can be a path of online as well. Means if you have data in your cloud. In this case, include subfolder store. So it will read the path of subfolders as well, and label source means class name of folder names. Whatever subfolders names are there, automatically it will be assigned as a class. Okay. Next, what we are doing is we are splitting this IMDS, the image data store, in a training and in a validation part. So 0.8 means 80% will be used for the training, and remaining 20% will be used for validation. Okay. And by this command, we are extracting how many samples are there. First layer will be image input layer. We have to find out the size of the image also here. So we provided that thing. I am going to run this. So here you can see total count. It is showing you for anger, total number of samples we have 135. Disgust, it is 177. So why we require to create an image data store? Because we cannot load all images at the same time in any software. Your system can be hanged for that. Okay. So that's why what we will do, we will take images from that image data store as a batches in a batches form. Like if number of batches, if I gave 20, so in a single epoch 20 batches will learn. In a single batch I can assign how many samples I want at a time to train it, and number of batches is called in this case as a iterations. Okay. So this we created a data store here, IMDS. So here you can see here this is a data store, and these are the path of all images. And for every images, automatically labeling is also done, because already the label name was as a subfolder name. Now we are going to define the layer. These layers you can define it from here also. There is a deep network designer which I show you in a video. You can use this deep network designer to create layers for you. Okay. And after creating the layer, we can verify that layers, and further we can export for the trend. Okay, let me explain that layer. So image, first layer will be, if you want to do it manually, you have to do like this. First is the image input layer, that is the size of image. We have a gray image, so 48 into 48. If it was a color image, then 48 into 3 it would be. Now convolutional 2D layer, it is used to extract the features. The filter size is, okay, this app is open. So I'm going to choose the blank layer. So here you can see this layers with, so here you can be design the layers, then export the data, and then train your data. So all options you can, everything you can do in a single app from MATLAB 2028. So here you can drag and drop your layer like this. Okay. And in right side you can provide the property of layer as well. Okay. Just click on the analyze. When you are happy with it, then you can export that layer for training your model. Okay. 3 layers only, so it will show me the of 3 layers. Still there is the issue because there we didn't provide that classification layer and softmax layer. That is very important. That's below which you can provide softmax layer and classification layer. Okay. So like this you can drag it, and you can, when you are happy with it, then you can use that for the time. Later I will show you LXNet how it looks like in that. So here first is image input layer, then convolution to layer. It is used to extract the features from it. Filter size is 3 and number of neurons are here 8. Then batch normalization there to normalize the features. This is a linear rectified unit. Whatever negative features will come, this rectifier will make it as a 0. Further, there is a filter size of 3 into 3. Means 3 into 3 means 9 features we are extracting. We are reducing that redundant feature, and we are converting as a matrix of 2 into 2. And further you can see these all layers are repeated with different size of neurons, 16, then 32, like this. And last 3 layers are very important. The fully connected layers, we provide the number of classes. Softmax layer is used to find out the probability that what is available in that image. It will find out the probability of every and based on this probability, classification layer will predict that what is available in. I'm going to run this. I created that layer. Now some option files. I want to plot the training progress. Solver I am going to use it. What is the initial learning rate? Okay, this is the hyperparameter. It is as a default. It is 0.01. So I am going to run. And further, this is a training, the model train network. In train network, that is a training data set, and the layers which we defined, and we provided the initial learning rate. So I am going to train this. And you see here number of epochs are 10. It means it will run for a 10 full cycle. And if I have a supported GPU, so right now I have a supported GPU, and it will run on GPU. So soon this training will start. So here you can see on the first graph, that is the accuracy with respect to iterations, and second is losses with respect to iterations. So accuracy have to be around 100% and this losses have to be 0. So my training is done for 10 epochs, and total epochs 10, total iterations 60. Total iterations 60 means number of batches are 60 as a default. Okay. Okay, now training is done. Next is to classify, means to find out the accuracy. First of all, validation. So what we are doing it, our model is trained here. We are using classify to classify the model and the samples which we already split it for validation. I will get a predicted output. Okay, and here already we have a original output. So what I am doing, I use the operator here, logical, and whenever this condition will be satisfied, means when predicted and actual outputs are equal, I will get value 1. I did the sum of that. It means that total number of correct predicted I am getting it, divided by total number of samples for validation. So if I run this, I will get the accuracy. The accuracy which is showing in this case, that is 0.9898, means 98.98% perfectly trained model. Next, I am going to check on a single image. I am going to read one image from validation. I am classifying it, and I am saying that what it predicted on that image. So you can see it's predicted as a anger, right? So it is showing me that a person is the image is anger. When you are happy with it, and if you have camera, you can apply on live camera, or just if you have IP camera, then you can use IP camera as well. Okay. So camera.snapshot, to take the snapshot, then convert in a gray, then resize your image according the images which you use during training, then classify it, then display the image and show that classification as a level. So it will run on a live camera. So for this I will show you one transfer learning, that how you can access your live camera. Okay. So I am going here, and this AlexNet I am going to show you. First of all, AlexNet, in AlexNet 1 million images are trained with 1000 classes. Okay. So if I train this pre-trained model again with 1 million images and 1000 classes, it will take 15 days. So why to train it again? Just use that pre-trained model for my data. Okay. Not only this, if you want to visualize this AlexNet layer, you can go here in Deep Network Designer. Already I loaded that AlexNet here. So from here, from workspace, import that model from workspace. Already it is in workspace. So this is a layer. You can see that here it is showing you that 25 layers are there in AlexNet. Right? How you are going to use model, this pre-trained? Let me zoom this. Okay, this. So if you have to modify this layer for your images, just change this size of your image. In this case, this is 227 into 20 into 3. Like convolutional layer, if you want to change some filter size, you can change like this, and you can further you can export or generate a code, and this pre-trained model you can use for your data. Okay. Okay, we were here. So what? Let me on the IP camera first of all of my, which I have right now. Just wait a minute. So in this case, what I am going to do, I am going to on the IP camera, okay, which I have. Further, I am running a loop for infinity while one. I am taking the snapshot from this camera. If you have IP camera and if you know the IP address and password, if it is password protected, you can log your images in MATLAB. Okay. And further, I am resizing that snapshot based on the AlexNet images which are trained. Then we are classifying that image. Then we are visualizing that image as what is in front of the camera basically. Okay. So I am going to run this model. Just wait a minute. So it will predict that what is in front of my camera, and it will tell you as an image that what is in front of that camera. So it is still running. First time it takes a little time to execute this. So now you see it is predicted as a laptop, right? Now I am making my screen here. Let's see that what is predicting. So it is showing that this is a monitor, right? If I run it again, it is showing that this is a home theater, right? Now I am going to move here on my keyboard. Let's see that what it is predicting. Now it is showing that this is a space bar, right? And if I go more near and if I click on this, it is saying that it is a computer keyboard. So like this, if you have IP camera or any kind of camera interface, and it will tell you that what is in front of camera. So this is a real time application using deep learning. Fine. So this was about the session of today. Now question answers. If you have any questions, you can ask me. And before that, just move on the piece by PPT again. So these are some upcoming webinars by MathWorks. If you want to join it, I will share this PPT later. So these are webinars by MathWorks. If you are interested, then you can join this. Okay. So that's all for today. Thank you everyone. If you have a question, I know that maybe if you are seeing first time machine and deep learning, it will be a little complicated for you. It will be going above from your head. Maybe it is possible, but at least you got that what you can do using and machine and deep learning and what kind of applications you can use for that. Okay, because right now it is machine and deep learning is very widely used. Nobody is going to use mathematical equations, and this is the future. Machine and deep learning, reinforcement learning, IoT, and all these things. Okay. Okay, to join this, it is available on MathWorks website. We'll provide that you can visit on MathWorks. There you can find out this. I guess everyone is unmuted. Everyone is unmuted.